Welcome everybody to our next session at the conference. My name is Maarten de Laat. I'm the co-director of the Centre for Change and Complexity in Learning here at the University of South Australia. Thank you all for joining the AI Playground session. So far it's been a full and a great day for the conference so far. And for Australia we're approaching the evening, but in other time zones we're just at the start of the day. So welcome to the conference and I hope you will have fun enjoying it. Please keep in mind that the sessions are being recorded. So if you miss anything or you like repeats, they will be available soon. So just keep an eye out on the website of the conference. Announcements will be made there, I'm sure. On the session today, we have Andrew Samajic and Eric Wang. Both are PhD researchers at our Centre for Change, Complexity in Learning at the University of South Australia. And we have Amber Chittenden, she's Head of Programs, and Cameron Shand, Learning Designer from the Bendigo Tech School, working in partnership with 14 secondary schools to advance STEM education and help them to solve real-world problems. In this session, we will introduce the AI Playground and use this to discuss how the AI Playground can be used to study student perceptions of AI, how we can use AI to develop learning analytics and real-time feedback, and we will present teacher experiences and expectations of teaching AI into the classroom. I will kick it off with the introduction of the AI Playground, and then we will advance through the sessions accordingly. So first of all, the AI Playground. It's a learning experience platform developed in partnership with the University of South Australia, MelCX. It's an AI development company using computer vision, and Intel. And like I said, we're working with the Bendigo Tech School in partnership with Wrapup University to understand how teachers will benefit from using the AI Playground in the classroom. So the whole idea behind the AI Playground is to offer learning experience into the classroom and help teachers to advance the use of AI or adopt the use of AI and provide kids with real playful learning experiences about the AI. So the whole idea is to engage students experiencing AI through play, and through play learn about it, ask questions, start studying what AI is capable of, and advance their understanding of AI to then also start training AI and developing models of their own. So basically our mission is to offer a playground where kids can take ownership over AI, play with it, and develop AI to follow their own imagination. At the moment, the kids can play and learn and play with AI. The kids can start developing AI, like I said, and part of it is also to engage kids into ethical discussions about how we use data, how we use AI, what are good and critical approaches to the use and benefit of AI in society. The AI Playground provides a safe place, and I think that's important to emphasize. The kids can play and adopt AI, but it's also in a controlled, monitored environment, similar like a playground in the classroom or at the schoolyard, basically. And the kids will be engaging in generating data sets, and they will own their own data sets. They can start helping improving the AI that is there, and they can develop AI models. Again, they will own their own AI that they are building, and they can use it to run simulations and start exploring deeper learning questions and solve their own problems, basically, with the help of AI. The whole idea is to engage kids in playful AI learning experiences and help understand how AI can advance our human capability, if you like, and have human AI partnership to start solving what we call like superhuman problems. Now, basically in the AI Playground, we will offer a number of AI challenges, and the teachers can use any AI learning challenge that they like and to offer that to the kids. So again, it's a space that will grow, and over time we will have a rich learning environment that schools and teachers can pick from. It's about understanding and developing AI. It's about using simulations and a sort of a game-based learning experience. I think we have dropped off. Maybe Amber might come back. I'm not quite sure what's happening there. Oh, there she is. But also the AI Playground will track engagement data and develop a kind of leaderboard, and it will provide real-time analytics to teachers to generate insights about the learning that's going on. So basically, we also encourage for teachers to start engaging in what we call an open online community. This is a space where teachers can share experiences and stories about how they've been working with the AI Playground, but more importantly also share lesson plans and lesson materials to create a rich environment for teachers to start adopting AI into the classroom. And all the materials will be offered for free, and the teachers can therefore be encouraged to start using those lesson plans, if you like, in their own sessions. The first learning challenge that we offer in the AI Playground is all about exploring life on Mars. And as you can see, it's not necessarily centering on AI, but the whole idea is that we have this huge learning experience and that the kids will understand how AI can be used to solve your own problems and how you can benefit from AI to understand life on Mars, for example. So in this particular case, the kids will be building a rover, and they will be doing this together with AI, and we will be using the LEGO EV3 Mindstorms for it. We will be using a camera to support computer vision for the kids to engage with the AI, and other edge devices to help support the learning as we go along. The AI will be used in three particular ways. At first, the AI will help provide the kids with feedback about the bricks or the Lego bricks that they will be using to develop their rover. So it's a good way of understanding what the Lego bricks are all about and what you can do with them. The second step is to help them building their actual rover, providing feedback as they go along. And as soon as the rover is built and ready, they can run a simulation with their rover and explore Mars. And there they can start using sensors, the sensors that are part of the Lego set, to start analyze or to start collecting data and analyze data using AI. So that's the third way of using AI, basically. So how it works is here, I'll show a short video just to see how the kids interact with the AI. You can see that the camera is here on the screen, and the AI is just looking down to the desk. And as soon as Lego pieces are being detected, it puts a box around it and it tells you sort of what are the Lego pieces about and how can it be used. So it's encouraging the students to start playing around and sort of understanding the bricks that are available to them, basically. In the next slide, you can see a short video where the kid is then sort of trying to understand basically what are these pieces for and how can I use that red little piece that he needs to secure the wheel on the axle of the rover that they're building at the moment. And basically the screen looks like this. So in the bottom, you have what we call a conveyor belt, and that's what the kids can use to start collecting all the Lego pieces they need to build their model. Now, the Mars rover is quite a large component, so we've broken it down in subcomponents, like this is the chassis. And the first step is for the kids to collect all the pieces that they need for the chassis. And then they can further interact with the 3D model here to try and understand how to build their rover. So they can put pieces on the desk again, and then a piece will highlight in the model, so you can get an exact sort of matching with sort of what are you having in your hand, or what is lying on your desk, and where does it need to go in the 3D model. And that's a way for the kids to interact and use AI as a teammate, so to speak, to help understand how this rover can be built. You can change or zoom into the 3D model. You can turn it around, and you can really start exploring where all these pieces need to go. So once that's done, the kids can then sort of travel to Mars. Now here we have a small example of a 5-piece set, but in real life they will be driving the full rover. But the AI picks up the rover when it's ready, and it releases therefore then the travel to Mars. And that's where they can drive their own Lego rover as a digital twin, like it's happening here. And that's a fun sort of game exercise for the kids as well. You can sort of drive around on Mars, you can visit the NASA Perseverance, and you can learn about the sensors and instruments that rover has to understand how you can collect data on Mars, like the SuperCam. Okay, so that's how the kids can, first of all, use AI to build a rover. And then as soon as they have finished it and the AI picks it up as a detected rover, they can travel to Mars, and there they can start using their own rover in a digital simulation to start exploring Mars, learn from the existing Mars rovers, explore where it's been and what it's been doing at certain spots on Mars, and then use that to start advancing their own rover and collect data about Mars itself. So further to this talk, we will explore sort of, okay, well, how does the AI playground help therefore then to start generating AI learning experiences and understand sort of student perceptions of AI. We will also be collecting through these learning experiences lots of data, and we're interested in how we can actually use AI to help analyze this data and use learning analytics or real-time feedback to advance the learning in the classroom. And we will look into how AI playground and the learning experiences can be used to understand the adoption of AI into the classroom. And all these three topics will be part of this session. So I think it's time to hand over to Andrew. Would you be so kind to start presenting your part on student perceptions of AI and collaborative learning?
Yes, thanks, Martin. Sure. So hello, my name's Andrew, and I'll be taking you through the studies Rebecca Marone and I have done involving K-12 teams when working the AI Mars rover. We've primarily investigated student perceptions in collaborative learning contexts after working with AI. So we examined how K-12 teams worked with an AI bot that provided them with feedback, including the level of completion and instructions when building the Mars rover. This was nicely illustrated when Martin presented the slides of what the kind of feedback and the work environment setup that K-12 students were part of. I don't know if you can go next slide.
Yep.
So the motivation for conducting such work is driven by the need for AI literacy and awareness. So, for example, there are very large expectations of what AI can do in a practical sense. Social media tends to over-exaggerate the capabilities of AI, and in many cases, students don't even realize that they are using a tool that's built with AI. Therefore, it's important for educators to realize the capabilities of what AI can actually do in the practical sense in the classroom. So for this study, we wanted to explore what perceptions of K-12 students were when working with an AI robot. This AI robot is considered a narrow intelligence, which is something that it's programmed to be good at a very specific task, most of the time better than what a human can do. Next slide, Martin. So what we have done, we've conducted a focus group after they've worked with the AI Mars rover bot, and asking them questions about AI knowledge, their feelings and experiences when working with AI. We've done a thematic analysis, which is to just identify the themes from the and develop codes based on their answers to our questions. While doing this, we realized that we could quantify the data and represent those codes as a network to further help illustrate what the perceptions are. So we've conducted something called a epistemic network analysis. So in short, epistemic network analysis, or ENA, it's a method for quantifying connections among coded data, right, and representing them as a network. So in that table 1, you can see kind of like an excerpt of a coded spreadsheet. You can see that in the activity, we've asked if they would work with AI, and we had the focus group number, and then in the text, we had their responses. Code columns, we've contextualized and came up with appropriate codes to kind of derive meaning out of the conversation. So the ENA, in a way, it creates a co-occurrences of the codes where you have nodes and connections between them to illustrate those connections. So in the next slide, I'll briefly cover this. So this is a packed illustration But to break it down, we've identified 4 main themes arising when it comes to the perceptions of K-12 students after working with AI. So we found we found some themes related to sentiment and trust, misperceptions, the actual power of AI and its impact on the future and their future, and also some of the complexities that happened when working with AI. So for each question that you see, we got 6 there. We conducted ENA on the codes to show the connections we identified as part of the thematic analysis that made sense. So these colorful connections you see between the networks and theme represent how the question and coded network fit with the overall theme. So to give a bit of a more detailed example, so for question 6, right, how was your experience working with AI? You can see 3 till nodes in a triangle there. If you look closely, they're quite close with thick lines of edges. So what this indicates that when students work with AI, they noted that they experienced, bugs and challenges when working with the Mars rover, but they have also said that it was an enjoyable experience. So it kind of provides a very nice, tangible and quantifiable result of the student's perception. So there are some other codes that you see there, examples of inaccuracy and some responses where some students might reject the idea of working with AI, but generally these students were very receptive and liked and enjoyed working with AI despite its flaws and its capabilities. But yeah, these all help with the in-depth interpretation of how students perceived AI after working with it. So on our final piece, next slide, Martin. Just wanted to share some key main findings. So out of the 4 themes, we could see that like a lot of the results that we found were already kind of met our assumptions that, K-12 students are sort of over-exaggerating a bit of the capabilities, and when they actually begin to work with the AI in some aspects, they are disappointed that it's not actually bringing out some of the capabilities that they expect. So, it's important thing that was identified is you cannot overpromise the capability of AI. It needs to be grounded in reality. So that's an important one. And there's also, we found when teams are working with AI, there's a bit of a lack of understanding of what AI has as a role as a teammate. So this is an area that needs further development and work. So and we've had some kind of interesting quotes by the students. Some students these days are very familiar with all the vendors like Apple and Microsoft and Amazon and the services they provide with the Siri and the like. And some students also expressed trust issues with particular vendors as well. So what's interesting is there might be let's just say trust in some vendors. So there are some students that trust certain products, ones that they want to work with, and this might be important to consider when educators start to implement AI. Who was the company that built this AI? Is their data safe? Is it going to be capable of, is it going to meet expectations? So, yes, that sums up some of the work that Rebecca and I have conducted in this K-12 environment, the Mars rover.
Thank you, Andrew. I think that's a wonderful overview of what you can achieve with understanding sort of the students' approaches towards AI in such a short span of space even. There is one question here from Xiao Hu that I think is worth addressing just at the moment. And he or she wants to know, how old were the students in the focus groups?
So
you speak of K to 12, eh?
Yeah, K to 12. So I would be more aligning that they were year 10s. Year 9s are year 10s, yeah. So they would be about 16, around 16 years old. Yep.
Mm-hmm. Thank you. I think Rebecca has already answered your question.
Yeah, awesome.
Just great to see this all working. Okay, I think that's probably best for. If there are other questions, we can always go back to this session later on, but it's good to provide some more time for the other presenters as well. So I'll move on towards Eric. Thank you, Andrew. Eric, can you start your presentation on learning analytics and real-time feedback within the AI playgrounds?
Yeah, thank you, Martin. If you can go to
the next slide.
Yeah, thank you. Just like Martin and Andrew introduced before, the AI playground is really a good platform that for students, from students' perspective, it is a platform that provide a place to enable them to solve a real complex problem, a design problem, by collaborating not only between themselves, but also more importantly, particularly collaborating with AI, the teammate that represented by the camera and the functionality behind the camera. While they playing in the playground, interacting with the AI, the data is also collected along the way. So how do we collect data? We use main three sources. The main one is the two cameras in the classroom. One on the table providing which is called the Viana system camera, which provides the scanning function, the main scanning functionality, the interaction functionality between the screen and the students and their Lego pieces and all those contents displayed on the screen. So that's the one camera on the table. There will be another camera called, we just call it the learning analytics camera. It will be a little bit away from the table, away from the student, but look at the students doing the recordings of the video and also the audio. That's the main source. Another source is a Viana system, which is the playground platform system. It's log, the events. Not among a lot of log files, we're particularly interested in the user-triggered events, such as a user hovering over in the platform, in the portal, hovering over to the AI component or non-AI component, playing with each different function buttons on the screen, and yeah, we will analyze those afterwards to further understand how they interact with the system, with the AI system. And another source will be the classroom engineering books or engineering notes that each group will need to finish by like handwritten ones. They will these books, written text will also be digitalized later on. So since we have this quite rich sources of data, we're gonna use this multimodal data to do some learning analytics. For real-time analytics, it will focus on the group dynamics and augment teaching, and how the group dynamics, the measurements that represent the group dynamics will augment teachers' teaching and student learning in real time. So that's the second camera's functionality. That's the LA camera's functionality. So we are hoping to leveraging all those data collection and those MMLA to answer some important questions that we're interested in, such as how to do the measurement and how the measurement can help teacher and the students. Yeah, if you go to the next slide, thank you, Martin. Yeah, talking about real-time learning analytics and feedback. Here's an example of what we can do. We can just streaming the video recording. This is an example, not from the classroom, but it's similar. We can augment the contents once we got the data points collected and the landmarks recognized and the pose we anticipated, estimated. So, for example, in this example, we use the landmarks number 11 to 16 to keep derived from these landmarks to calculate their arm movement and arm reaching out and reaching out and coming back to have an understanding of their interactions. This arm moving can be interacting with Lego pieces or can be scanning pieces to the Viana camera. But also we can be creative to make use of other landmarks to come out with other features that we're interested, such as bodies, upper body, or any reliable visible landmarks can all be used to do the derive. Next slide, please. Thanks. Apart from that real-time example, here's some more data measures we can do, and so far we can think of and we prototyped. So, for example, on the right-hand side, we just list 4 examples. A group time, on task, off task. This is the feature, the measurement we can derive from text. Once the audio is recorded and is transcribed into text, we train the model. We have the model to identify according to the content that they're talking about to automatically derive the on-task content and off-task contents together with the timestamp recorded for every data measurement. We can come out with the overall meaning, overall time on and off. Same as, I will not go through the details of everyone, but same as a group average height and also the group physical density, which is all the information we captured from audio frames, from video frames, and also the voice, the audio side is the superficial feature would also be useful to understand the group dynamics, such as they have a lot of pauses at the starting, less pause in the group in the middle, and almost no pause toward the end of the lesson. And that's the 4 example, plus some other text from the logs. Based on the previous data measurements and all those the data availability, we can come back to our research question, all the questions we're interested in, how those data measurements, if they can be measured, how they can help us to answer our questions. You can see on this table, whatever marked yes or jointly yes means they are measurable towards in accordance with the particular question that we want to seek, we want to understand. Some questions, for example, engagement, collaboration, and CPS, complex problem solving progress, that's useful for both students and teachers. And some other aspects like student sense making, knowledge construction, how they construct the knowledge and how do they make decision will be particularly useful for students. So we're hoping with all this playground available and all those data, multimodal data and learning analytics happening, we can use this to measure and inform teachers of how students achieve how they're doing in the playground, and how we can keep better using of this playground. Thanks.
Thank you, Eric. I think that's been a good summary and a great presentation talking about how we can actually use data to provide learning analytics feedback in real time. I'm sure you will also be collecting data and analysis reports that are used more post hoc, that are not necessarily real time. But this is more the focus on generating real-time feedback to help teachers, I would say, with the classroom management of working in the playground.
Yeah, there will be more. Yes, thanks.
Yes, thank you. I'd like now to move on, because I don't see any pressing questions in the Q&A. So people, if you have any questions for Eric, just post them and we will address them later on. But now I'd like to move on to our final presenters, which are Amber and Cameron, to talk more about how the AI Playground will help generating teacher experiences and what their expectations are of working with AI tools such as the AI Playground. Okay,
Fantastic.
Thank you.
Thank you so much, Martin.
Yep.
So just to introduce myself, my name's Amber Chittenden. I'm the Head of Programs at the Bendigo Tech School. Now, the Bendigo Tech School, to provide you with some context, is a high-tech learning hub in which students attending the local schools in our region, of which there are around about 14,000 students across our region and 16 partner schools. They undertake the latest technology, discovery and innovation pedagogies that we know our students need in Victoria to succeed in a rapidly changing global economy. So I work with Cam. Cam's one of our learning designers here at the Bendigo Tech School. And what we're doing as part of this model is on the screen, you'll see our aspiration model. It's around tying together curriculum and programs and linking with industry so that our students can develop opportunities to engage in critical and creative thinking, innovation, problem solving, communication, while also enhancing their leadership, teamwork and entrepreneurship skills. So all of our programs follow and utilise the Stanford design thinking process, as well as making sure that each one of our outcomes are aligned to industries, really making sure that our kids are able to work together to solve real world problems. On the next slide, you'll see some information around our 6 future industry job areas. So we have food and fibre, health and medical, advanced manufacturing, transport, construction and defence, which is where we're tapping into AI at the moment with AI Playground, new energies, as well as professional services. So each of these students work through our programs which are linked to those areas, and it allows and encourages us to be able to connect specific industries with education to inspire students and encourage economic growth within our region. So I'm just going to hand over to Cam. Cam's going to talk a little bit about what our learning intentions look like and in terms of AI Playground in the classroom. So Martine, I'll just ask you to switch the slide to the next one. Thanks.
Awesome. Thank you, Amber. Yes, my name is Cam, one of the learning designers at the Tech School in Bendigo. Now, as you see on the screen with our learning intentions, this is the slideshow that students do see when they come in at the start of the day, and we run them through the activities they're going to do. So to use AI and getting hands-on with it, they did some generative art, played with some different online AI bots, and then also explored generative adversarial networks and how they kind of work, leading us into how could they use AI Playground with the camera recognition to explore Mars and build their little rover. We have got their block code and text code, so they do play with robots, but that's not really pushing on the AI. That's more so just looking at sensor data input. But we kind of try to build their understandings of, how could they embed this into a robot, but we don't expect them to code an AI robot in one day. Next slide. Thanks, Martine. So prior learning to the day where they came in and used AI Playground, they did the Day of AI, which is I guess a great overview of what AI is, and it got some really good debate going on with the students as to where is AI in the real world, and they kind of I guess challenged each other's answers there as to different apps and features. But the one that they I guess I really loved watching them use was we got them to use the Google Teachable Machine to train rock, paper, scissors. And immediately after we got them to complete that task, you can see kind of in the background on a laptop screen there, students started training their own custom class of Dwayne The Rock Johnson, and they were doing rock, paper, scissors or holding the iPad up and seeing if their machine would recognize his face opposed to a rock fist, which was quite funny. They just intuitively did that. So they were loving using AI there. On the
And
next
just
slide,
to provide some context, Cam, before we go on, that students that are coming to us haven't been exposed to AI. So we're talking about things like teachable machine and testing image recognition. And this is a really high level topic for these kids that are coming in with maybe basic block coding understanding. They might do a little bit of typing and making some slideshow presentations at school, and that's really the extent of their digital literacy. So it's around engaging these kids, but providing a scaffold to support them through that. And we'll talk a little bit more about that later in terms of what that looks like in teaching and learning.
Yeah, excellent. Good context there, Ember, because they're not studying AI at uni or anything. These are high school students. So the tasks that we give them, we created this little handout to go in part with the AI playground whilst working with Martine. Now the first kind of task is pretty basic. It's just put the Lego pieces in front of the camera and see how it recognizes it. And they didn't seem too like surprised or, like they enjoyed it, but like they're kind of like, oh yeah, cool, it recognizes it's a Lego piece. Like they were like, I've seen a camera do that before. But what they really enjoyed was when they started putting the pieces together, or starting to put other pieces of things that shouldn't be in front of the camera. So if they put a pen down or a piece of the Technic, you can see a little black piece of Lego Technic there on the desk, something that shouldn't be a part of what they're trying to build. And it told them that it's not that. They kind of enjoyed that process a lot more. So kind of like tricking the camera. Which you can kind of see in the middle of that little handout, we had a section where we said to try and draw a Lego piece. And they loved that, being able to draw with their pencil and then hold it to the camera, and it actually would recognize it as a piece of Lego. So it was quite good, especially if it was like a black piece, dark piece of Lego Technique or something. It would recognize it, and they were quite excited with that. The last part of their handout, we got them to explore Mars. So they go into the part where they drive around the mini rover and explore, and they really enjoyed the gamification of this element. So they get an Xbox controller, and we got them to do one of the questions on the sheet or on the mission log, and then pass the controller to the next student. So although they're working as a group to build the robot, when it comes down to that kind of single player element, they can still work as a group to kind of point out where they should try and go on the map and explore next, and then share that controller around us as well between each other. I think Ember will jump in here.
Yeah, each of these opportunities, it sounds really basic because, again, we're dealing with students that are from year 7, so around 11, 12 years old, through to about 16. And again, it was an introduction to AI. So just getting them to understand how machines are teachable, and also getting them to look at camera recognition. I guess it was a fabulous opportunity for students to be able to employ basic AI functions to solve problems, to explore what this looks like in terms of the real world and how it's being used in industry, as well as to develop an understanding and utilisation of the design thinking process. So this was just a scaffold, an early scaffold as part of an engage activity. We think about the 5 E's in terms of pedagogical model. It was an engage type activity to really get those creative juices flowing, but to be getting those students excited about the possibilities of what AI could look like. So that takes us into the next little section around curriculum. Now, I've just provided how we've mapped AI Playground, and I know that it's really little on the slides, but just showing you that for all the educators that are in the room right now, or industry connections, that AI programs and the teaching of AI in schools is a really new opportunity. And being able to work with AI Playground and Martine, who we met at a conference and said, oh yes, we want to try this, has just been a phenomenal opportunity for our kids in the regional context. It's been about making sure that we are allowing students the accessibility to engage in a meaningful way, and that where AI Playground allows us to give ample space for students to explore broadly in the many directions, which was what Martine was talking about earlier. So it's within the confines of the curriculum, but really allowing students to think outside the box. In terms of a teaching and learning opportunity, knowing the curriculum, which is our job as teachers, and delivering it is as important as knowing each student. That's a really broad, sweeping generalist statement, but part of our Australian teaching standards is knowing the curriculum and knowing how to teach it, and as well as providing students with opportunity and knowing each student and their point of entry. So again, this scaffolded approach to AI Playground allows us to provide opportunities to support students to achieve their best learning outcomes. Now, in talking to the students that came along for our program, so one of our students, Michael, said that it really allowed him to learn in a way that was relevant and motivating to him. He loves astronomy, and being able to unpack what Mars looks like through an AI lens was really empowering for him, which was great feedback. And I think AI Playground for us allowed us to directly increase the students' ownership and responsibility in their learning, rather than just following a set of methodical procedural instructions. They were exploring, they were harnessing their curiosity and building their AI literacy and developing opportunities for themselves to develop critical and creative thinking and utilize innovation and problem solving, which is our whole mission at the Bendigo Tech School, making sure that we are providing the opportunities for kids to undertake those skills. Martina, on the next slide, it will talk a little bit, and I'd just like to talk a little bit about like the 4 C's and what that actually looks like. So I just touched on the critical and creative thinking, but we know as educators and people in industry that young people in the 21st century need to be innovators. They're going to be entrepreneurs. We are hopeful they are lifelong learners and that they are responsible global citizens. So our programs and what we tried to do as part of working with AI Playground and Martine and the crew was to make sure that the program was underpinned by the skills that students are going to need in the 21st century. So those 4 C's, critical thinking, creative thinking, communication, collaboration, and teamwork, as well as building the personal and social skills and ICT capacity. We know that 21st century learning, or the 4 C's as we call them here in Australia, is a really valuable skill set for the future. And we know that they're critical in a digital and evolving economy. So for our role here is to be a high-tech hub of innovation at the Bendigo Tech School. And it's to provide best practice in STEM education that's complementary to the 21st century, or 4 C's, those skills that we're engaging students in to promote lifelong learning and the critical thinking aspect as well. So just finally, on the final slide, just before we wrap up our little area, you'll see, and Martine, if you can push forward to the next one, where to from here? And I'll ask Cam to jump in on this one as well. But essentially, Lego Mindstorms EV3, what's really appealing to us is that working with the couple of thousand teachers in our region and the thousands of students in our region is that every secondary provider in Bendigo and beyond has Lego Mindstorms EV3 kits in their classroom, mostly collecting dust, which is a little bit scary. So what we're trying to do as part of this program is to empower teachers to be able to understand and utilize the EV3 Lego Mindstorm kits and to be able to integrate them into their teaching and learning capacity to inspire the next generation of coders, of people interested in machine learning, in teachable machines and AI. Because, where to from here? We want to take those dusty kits out of the back room of the cupboard and bring them back to life in the classroom. And AI Playground has been a fabulous opportunity to be able to do that. So we're just really grateful to Martine and the crew for having us along to be able to inspire these students. Where to from here, Cam?
Yeah. Well,
what does it look like for you?
I was going to say it's great that the schools, they have these kits. So that's when I saw it. I walked past the EduTech stand with Martine there, and I was like, I've got to show Ember this. Like, they're using EV3 kits with AI. How good's this? Because, for example, when we're going through some of the lockdowns this year, we ran remote sessions with the EV3 kits, teaching the students how to program them, and that's in part because the teachers aren't confident with using this technology or programming them in certain ways, so we remote into their classroom. But the power of this AI Playground here is it becomes that tool, that buddy, the extra thing that teachers can lean on. So they might not be confident in running the students through certain tasks themselves, but if they can, get the webcam set up, get the AI up and running, it can help them co-deliver and facilitate the information they're trying to get the students to do. So just like we did, we can remote in, we can run it, with we can still run it with them. But once you've got this stuff kind of off the ground, and the teachers have the kits there, they can put them on the table and give the students that agency to build their little Mars rover themselves. So it's going to be really exciting to see as it evolves and we start rolling it out throughout next year and teaching it, I guess, as a part of one of our general offerings of the program. But yeah, it's been exciting to see the students use it so far.
Thank you,
Thanks,
Cameron.
Cam.
I think those were at least probably your final words on this presentation. I'm not sure, Amber, did you want to add something? Or, yeah.
No, I think Cam certainly wrapped it up beautifully. So yes, thank you for that, Cam.
Well, and thank you, both of you actually for embracing, if you like, the AI playground, because this is exactly why we developed it. We want to provide these meaningful experiences, but almost like an out-of-the-box experience. So not making it too difficult for teachers to, first, learn a lot about what AI is, how it works and stuff like that. It's more about, engaging through play, if you like, and using the EV3 mindsets to start, or the mindstorms, I must say, to develop this Mars rover. The AI is just like, as a teammate or an assistant on the side, if you like. The kids can decide to use it, they can ignore it. And I think that's part of our research as well, to really understand to what extent are children sort of accepting AI, or how are they interacting with AI? Do they find it useful or not? And I think these are the kind of partnerships that we need. We need industry to develop high level and great quality programs and technology to go with it, but also working with you guys and schools is really important, to understand what are the teacher needs, what are the possibilities and the hurdles that we will encounter along the way, and how can we collaboratively try and solve them. And I think part of the session today is to really provide those different perspectives. It's offering learning experiences. It's also conducting research about understanding students' expectations and teacher expectations, but also understand, okay, what is the capability beyond, if you like, the AI playground as a learning challenge, but what other data can be captured along the way to try and provide teacher feedback. And I think that's quite an interesting sort of constellation of approaches that are all part of it that will help driving this AI playground agenda forward. There is a question in the chat that I see, and it's from Simon. And the question is about how much benchmarking of learners' initial epistemological frameworks is undertaken with these individuals. How homogeneous a group of learner are they? Now, with the benchmarking of initial epistemological framework, I'm not entirely understand if you're talking about, do they need to have a basic understanding of AI in order to work with it? In that particular case, the answer would be no, because the whole purpose is that it's a low entry level. So it's almost like you turn the computer on and the AI is there, and you can put your Lego pieces on the desk and you will get your instant feedback, and you can decide to see whether that's useful for you or not. And like Eric was saying, in terms of logging, the data event log will also keep a very close track on to what extent are kids actually using the AI camera feedback to detect where the pieces in the model sit to help facilitate building of the rover, or do they move that screen to the side and they decide to only use the 3D model and as a group task, talk amongst each other and try to figure it out themselves. And that sort of dynamic is interesting, because understanding at what point in their progress are they calling upon the AI to see if they need some further assistance for their build or not. And I think that interplay is really interesting. And something that I didn't say is that while the kids are building their rover, they can keep on training the AI model. So first of all, they can reinforce through training of the AI to keep on saying that the AI is detecting the right pieces. So if it detects a wheel and it is the right wheel, you can sort of say, yes, that's true. Or if it's not correct, you can say this is incorrect, and then you can reclassify by using some pull down menus to select the piece that it is, so they can keep on improving the recognition capability of the models. But at the same time, the event logs are also being used to understand how the kids are actually building their rover. And there might be multiple pathways to that particular rover. So collecting user feedback and user data will be another way for the AI to become stronger or more powerful along the way. So at some point, if it's trained enough by the kids, the AI can start predicting what the next piece will be that they need to complete or to build their rover. And as soon as those kind of capabilities become available, I think that's quite an interesting way to start understanding how they actually contribute to the AI and make the AI smarter, and therefore developing your team. And these differences can be team specific. So if one group decides not to train the AI, their AI will stay as is. Other groups that will do it, they might have a smarter AI in their group compared to the other groups, and maybe some other groups decide to completely mess it up, like that trickery, I think, tricking the camera, or like drawing those AI, on drawing the Lego pieces. I think those are really good examples of where kids will start to explore and play. I like that example about Dwayne "The Rock" Johnson. Now, I would never have thought of something like this, but the kids are just, they're imaginative. They come up with things that you would not expect, and I think we can learn a great deal from it. In one of the earlier sessions that we had a similar response, like kids were playing with or interacting with the pieces, but at some point the camera was picking up a wristwatch, and it was detecting it as a wheel because it was just like a black rubber circle basically, and the kids were like, it's a wheel. How come the AI sees it as a wheel? How come it's so stupid, or it makes mistakes and stuff like that? And in a way, I think that goes back to what Andrew was saying as well. It's understanding that sort of narrow AI, or where AI is at the moment, and how we can work and play with AI to our advantage. Now, sorry, that was probably a bit of a long answer to that particular question, but I just wanted to emphasize that that's part of what the kids will be doing. Now, the other question that Simon asked is about how homogeneous a group of learners are they? And I think I might just throw back that question to both Andrew and Cameron and Amber to sort of get a bit of a picture of the focus groups that Andrew was working with, and the students that you were working with during the Day of AI. So maybe, Andrew, could you say a little bit more about if they were a homogeneous group or a very mixed group or whatever?
Yes, so they were very much a mixed group on a wide spectrum. So you had teams with students with different abilities and skill sets, right? So, but every team worked on the same way with the AI robot. Every team member in the team participated, right? Regardless of what their background was or what skill level they're all participated, they all learned something, and they all developed their own personal views and opinions based on their experiences, right? So they're definitely very much a mixed group. But when it comes to similarities, they are from the same year level, roughly the same age. It's a nice even blend between gender and just mostly a bubbly bunch, positive students looking forward to play around with cool technologies. So that's as much as I can say about the composition of the group of learners.
Thank you, Andrew.
I can jump in, Andrew. Our students that we had were very mixed ability from different schools as well, so different socioeconomic status schools as well as different age groups. So we had students between year 7 and 10, which in Australia is around about 11 years old to about 16 years old. Within that group though, we had, now in Australia we would say additional learning needs, kids who might have additional learning needs or be maybe how they're referred to in America, etc., would be below level, but then at the same time have at grade students or at standard students and above expected level students according to our curriculum as well. So really mixed ability, but remembering also there was a bit of a leveling in the playing field because these students hadn't been exposed to AI in the classroom. As I said, that it's still very new here within our context in Victoria anyway. And this was a really unique opportunity to provide insight into those, or for those kids, into AI and what that can look like. So in a nutshell, they were, just as Andrew said in his focus groups, they were a very enthusiastic and bubbly bunch. Again, we had the full gamut of skills from around about a grade 3 Australian level, looking at the data that we get from the schools when they book in, through around about a year 10. So that's a 7-year span of curriculum levels. But again, they had limited exposure to AI, so it was all new. They were willing to give it a red hot go. And it was just phenomenal for kids to be able to have that agency to explore and to be inquisitive and curious and to test things and to push boundaries. So, yeah.
Thanks. I think that's wonderful. I was wondering, the Bendigo Tech School, is that a unique approach within Victoria, or are there similar schools across Australia?
Yeah, so it was around about 5 years ago, the state government of Victoria rolled out tech schools in Victoria. So it's not the traditional tech school as what you would think about in the 60s, 70s and 80s and even early 90s. It's not necessarily a place to go and learn woodwork or metalwork. Tech is referring to a high-tech hub of innovation. So we're using industry-based and industry-standard equipment like laser cutters, 3D printers, mixed reality headsets, virtual reality, AI, et cetera, to be able to engage students. So Martine, to answer your question, there are 10 tech schools, so 10 standalone tech schools like us, all in Victoria, all hosted within post-compulsory education providers such as La Trobe University, like we are, or Monash University down in Melbourne. There's Box Hill TAFE hosts another one. So there's 10 tech schools across the state, but there's also 8 science centres or kiosks that comes under the tech school model as well. So for us, we're all about providing, if we think back to that aspiration model that I had up at the beginning of our little presentation, our aspiration is to have community and industry and curriculum all melding into one. So we're the conduit between what happens in the classroom and what happens in industry. So we can actually develop opportunities for students to engage in these innovative problem-solving programs. Hope that answers it for you.
Yeah, no, I think that's perfect. Keeping an eye out on the time, I think we're sort of approaching the end of our session, and I don't see any further questions in the chat, so I'm just having one other quick look. So I think this is a good moment to just thank you everybody on the panel. Thank you, Andrew, Eric, Cameron and Amber, for your great presentations and your contribution to the AI Playground, and I'm looking very much forward to keep on working with you all to develop this concept and bring AI into the classroom. Thank you also to the audience. We've had a great session, good participation, and like I said, this session will be recorded, so if you would like to revisit it again, just by all means, just visit our website and have fun, basically. Okay, and just keep on enjoying the rest of the conference. We have 2 more full days to go, and I hope we can welcome you back at a later stage. Thank you all, and have a good evening or a good day. Cheers.